Hello, and welcome to the first in a series of THERMOS training videos. This video is about getting started with THERMOS. Afterwards, you should have learned how to create an account on THERMOS, how to start a THERMOS project and what a project is for, how to create a THERMOS heat demand map from OpenStreetMap data, and finally, how to draw a heat network and evaluate it. Let's start by creating an account. Before you can use THERMOS at all, you need an account on a running copy of the system. Creating an account is what allows THERMOS to keep your work private to you. At the moment, you can access a running copy of the system at this address here, which you see on the screen. It's also displayed in the comments below the video. So if you visit this address in your web browser, you'll see a page somewhat like this. The browser I'm using here is Google Chrome, which is what we would recommend at the moment. And all you need to do is enter an email address in this box and a password in this box. I've done this before, so I don't have to click create here, but if you're new to the system, enter an email address and a password and click create. If you've already got an account, you fill in the details and click login, and you'll end up at a page like this. This is the THERMOS sort of home page for your user. Once you've made an account, you can also tell THERMOS your name as well, if you like. If you click on settings here in the top right, it takes you to this page which contains the details for your account, and you can tell the system your name if you want, which will allow it simply to display this in a way that's perhaps clearer to people you collaborate with. I don't need to change my password, so I'm going to clear that box. And if you click save, the system will remember your settings and display your name for yourself and indeed for other people. So now that we've made our account, we can start a project. All work in THERMOS is contained in projects, and a project is a place where several people can share some work, and everyone who has access to a project can see and modify all of the work in that project. To make a new project from the THERMOS homepage, click here on New Project. Now, every project has to have a name, so we'll enter that here, and you can also give the project a brief description, and you can give a list of names and email addresses here for people you want to collaborate with on the work. So I'll call this project Training 1, maybe with an uppercase T. And I'll put under the description a project for the first training video. Clicking Create Project takes me to this page here, which says the name of the project at the top, the description I gave here, and otherwise is fairly sparse because, as it says here, this project has no maps in it yet, and if we want to do anything, we need to create a map using the buttons above. So a map in THERMOS contains a set of buildings and roads which are the elements from which we may want to construct a heat network. So to continue with our work, we need to create a map and populate it with these buildings and roads. To do this, or start the process off, we're going to click here on the Map Plus button, or New Map button, which takes us into the map creation process. So the first thing which we have to tell THERMOS about our map is again a name. This is simply to help you know what it is you're working on. So I'm going to call this Bristol Training, and maybe I'll say in here a map for the first training video. Having filled these in, I can click Next to go to the next page. So the first question you're asked here is about where you want your building data to come from. As it says, heat demands and heat supplies are associated with buildings on the map, and there are two ways you can get this kind of information into THERMOS. The first way is to take the data from OpenStreetMap, which is a public collaborative project to create a world map, and you can edit yourself if you want to. And the second option is to use your own GIS data if you have other information which you know is better, which we'll come on to in a later video. For this video, we're going to have a look at using OpenStreetMap. So I'll scroll down a little bit, and you can see that here there's a small excerpt of OpenStreetMap, and there's also this search box which allows you to look for a place. These places are found in a database provided by OpenStreetMap called Nominatim, which contains the locations and boundaries of quite a lot of different sort of administrative regions and cities and so on and so forth. So I'm going to search for Bristol, and you can see a bunch of different results have come up. I'm looking for the Bristol in southwest England rather than Bristol, Massachusetts, or Bristol, Tennessee, or whatever. So I'll select this one by clicking on it, and you can see the map's moved to Bristol, and indeed there's this blue polygon drawn, which is the outline of the administrative boundary. For the purposes of our video, this polygon is perhaps slightly too large, so rather than simply importing all of Bristol, I'm going to zoom in a bit, let's say to this box, and just work in this region here, which I've selected. So just to go through that again, if you want to select a particular region from OpenStreetMap, you can either search in here for a named area, or you can locate somewhere on the map and then draw a box. So let's take this box here. Once we've selected a box, scroll to the bottom of the page and click Next. So the next question is about where roads come from, or roads and other paths. So THERMOS uses this GIS information to decide or to select where heat pipes can be considered for connecting one building to another building. And again, you have two choices. You can take roads out of OpenStreetMap for the area that we selected on the previous page, or alternatively, if we had a set of roads drawn in a GIS program, we could upload them here, but we'll come on to that in a later video. So for now, I'm going to use the roads from OpenStreetMap and click Next. Finally, we have to give the model one other piece of information, which is the number of heating degree days per year in the location, relative, as it says here, to a 17-degree base temperature. So heating degree days are a kind of useful summary fact about heat demand in a particular location, and you can look these up online for different places, or consult a statistical gazette for your area to find out more. So I'm going to put in 1600, as that's a realistic number for Bristol, and that's it. I can click Create Map, and as you can see here, it's having a little think and proceeding to find the geometry from OpenStreetMap. It will then do some demand estimation, join up the roads with the buildings to ensure that each potential demand is connected to the network in some way, and do a bit of other housekeeping and put it in the database. So we'll wait for that. One of the things you can do with THERMOS is to draw a heat network and then ask THERMOS how good it thinks that network is. Let's do this now in the map that we've just created. First, click on the New Network button to start drawing a new network. After a moment, the THERMOS network design page is shown, centered on the area that we've imported from OpenStreetMap. Hopefully, this satellite image is a little familiar from the map that we were looking at a few moments ago. The network design page is divided into three main parts. In the top left here, you can see a map, which you can use to select and manipulate buildings and paths for your network, and to view spatial information about results from the model. On the right here is the selection info page, currently empty. We'll use this later to view information about particular buildings and paths that we've clicked on in the map. And finally, at the bottom is the candidate table, which is also currently empty. This shows information about the particular buildings and paths that we are thinking of including in our network. Within the map, there are several controls which you can use to show what's presented. In the top right here, there's a search box which you can use to find particular places, street names or other locations. Below that here are the layer controls, which you can use to hide and show different types of information on the map. The top three control the so-called base map, which is the information displayed underneath everything else. So we can turn it off entirely. We can switch to displaying, which has caused the candidates layer to display. We can switch to displaying a cartographic map, or we can display satellite information. Below that, we can see three other controls which allow us to turn on and off different types of information that's displayed on top of the base map. So if we turn off the candidates layer, it disappears again. And we can also turn on the heat map, which is a heat density estimation. And we can turn on labels, which are just the names of particular places or streets on the map. I'll turn both of these off again for now. In the top left, there are these buttons which control the zoom level of the map. So you can click this button to zoom in and see a narrower area, or this button to zoom out and see a wider area. You can also zoom using the scroll wheel, so scrolling up will zoom in, I think, and scrolling down will zoom out. Finally, if you want to zoom to a particular region, let's say over here, you can hold down the Shift key on your keyboard and then draw a rectangle, and the map will zoom to that rectangle. To ask THERMOS about a network, we need to tell it which buildings and which paths we're thinking about using in our network. These buildings and paths are collectively known as the candidates, so we'll turn the candidates layer back on so that we can see some buildings and paths. And let's zoom in a little bit more, let's say on this central area, so that we can more easily see what we're dealing with. I'll zoom in a little bit further still. Right. So, as I said, to ask THERMOS about a network, we need to tell it which candidates we're considering, and this is a two-step process. First of all, we need to select some candidates using the map, which puts them into the selection, a sort of temporary category of buildings that we're sort of looking at. And once we've selected them, we need to mark them as being part of the network. Let's look at selecting some buildings. The simplest way and the most direct way to select something is just by clicking on it. For example, if I click on this building here, you can see on the map that the building's color has changed to be a darker shade, and the line around it has become thicker. This is how visually the selection is indicated on the map. Once we've selected something, you can see here on the right that the selection info panel displays a bit of information about what it is that we've selected. In this case, it's telling us we've selected a single candidate, this one building over here, and that it is a building. It is currently unclassified. It's forbidden from consideration as part of a network. It's called the King David Hotel. It's on the standard tariff, or it would be if it were connected to a network. The connection costs, which are part of that tariff, are currently set to 0. And the demand estimate's 89 megawatt hours a year, with a peak demand estimate of 66 kilowatts. If we select a path instead of a building, for example, by clicking on this small segment here, we can see that the selection info window tells us some slightly different information. In this case, it tells us the civil cost parameters, which determine what it would cost to put a pipe in there, the length of the path, and gives us an estimate of the cost of digging up that path to put in a relatively small pipe. Now, as mentioned, to ask THERMOS about a network, we need to construct a set of buildings and paths for it to think about including in the network. And to do this, we perform two steps. The first step being to select them, which is what we've done with this piece of path here. And then the second is to mark them for consideration in a network. There are two ways to do this. The first way, which is the quickest way, is to press the letter C on the keyboard once you've selected something. So pressing C, as you can see, has done a couple of things visible on the screen. It's changed the color of the selection to blue. That's the color that indicates that something is allowed to be in a network. That's displayed over here for the selection by a change in the constraint box, which has also turned blue and now says optional to tell us that this is an optional part of a network. And finally, the selected element is now also displayed in the candidates table at the bottom of the screen here. So by repeating this process of selection and changing the constraint, you can see how it's possible to build up a set of candidates which can form a network. Let's do a little bit of this now. So I'll select this building, press the letter C, again changing its constraint to optional. I'll select this small piece of path here, maybe this piece of path here. We can go down this road a bit. And let's connect all of these buildings as well, why not? Oops. So now you can see on the screen a very small candidate network that we've constructed. Putting together a big network like this would, however, be perhaps a bit too laborious. Fortunately, THERMOS offers us some tools to speed this process up a little bit, which are these next icons here in the tools area on the map. If we zoom out a bit, we can have a go on these. So the first one here, draw a polygon, lets you select buildings in a polygonal area. So to use that, click on it, as I just have, and then make a series of clicks describing the perimeter of the polygon that you're interested in. Finally, click the first point to finish the polygon, and you can see that THERMOS has selected a bunch of things which all intersect with that polygon I've just drawn. This multiple selection also shows us some further features of the selection info panel. When you've selected a bunch of candidates at once, the information that's displayed in here covers all of those candidates. So in this case, it says here, I've selected 108 candidates, of which 29 are buildings, 79 are these small pieces of pathway. And then you can see here a bunch of different classification facts, which tell us about the types of the different things that we've selected. In each case, there's a small number here on the left, which tells you how many things are in that category. Similarly, you can see there's 23 things, which are the things I individually selected earlier, and then 85 remaining things which are forbidden. You can see the names of all these different things that I've chosen. And finally, you can see summaries of the quantitative facts about them. So in this case, I've selected 700 meters of path, which would have this total cost to include, and I've selected 1.3 gigawatt hours per year of demand and a total peak demand of 1.2 megawatts. Having selected all of these things, I can once again change their constraint status by pressing the C key again, and they all change color at once. So this is a much quicker way to select a bunch of things to consider in a network than individually clicking on them one at a time. Let's select a slightly bigger area, demonstrating the other selection tool, which is the rectangle select. So this just allows you to very rapidly draw a simple box like this. And again, I can flip the constraint status of these elements, adding them to our problem. I'm going to turn off the satellite map now because I find it introduces more sort of visual noise and doesn't really help me very much. So you can see here now on the map that we have the outlines of a network we might consider constructing. Once you've made a selection of buildings like this and converted them into candidates, you might also want to turn off the display of candidates which are now sort of extraneous to your consideration, which is what this button here does, where it says hide unconstrained candidates. Clicking on that shows us only the things which are in this table, so those are the things which we've colored in blue. So as promised, now that we've selected a bunch of candidates for consideration in a network, let's get THERMOS to evaluate a simple network which connects up these buildings in some way. Before we can do that, there are two steps left. The first is to define a supply location for the network. So to do that, let's select one of the buildings on the map, let's say this one, and convert it into a supply location. To do that, press the S key on the keyboard, which will bring up this small form, allowing us to set the supply parameters. So let's say a maximum capacity of 3 megawatts. Let's give it a fixed cost of, let's say, 100,000 currency. And let's say an additional cost on top of that 100,000 of 300 currency per peak kilowatt of installed capacity. And let's say that the plant can introduce heat into the network at a cost of 3.5 cents per kilowatt hour, and that doing so produces 350 grams of CO2 emissions per kilowatt hour of heat introduced into the network. Having filled in this little form, we can click OK, and you can see that the building has turned slightly stripy on the map, which is the way supply points are displayed to make them look different to the other buildings. So in this configuration that we have displayed on the screen, everything is blue, which means that everything is optional as far as the model is concerned. So in this setup, THERMOS will try, when we click Optimize in a minute, this button up here, THERMOS will try to select a set of these optional components that maximize the net present value of the network that gets built. We'll go into that set of controls in a bit more detail next time, but for now, let's say that we want to build a network that connects every building we can see on the map here, no matter the financial cost of doing so. But the system is free to choose a route from the different ways you could use the paths displayed on the screen. So to do this, we need to select all of the buildings and change their constraint status from blue, which means optional, to red, which means required. So one way to do this would be to click on each of these buildings in turn and press the letter C, changing them from optional constraint over here to required constraint. But as you can see, this is sort of a laborious process, and you know, it's a bit tricky. If you click on things that are quite small, sometimes you might hit a bit of road as well, and we're not trying to change the roads. So fortunately, there is a more efficient way to do this in THERMOS, and a lot of different kind of operations manipulating the selection fall into this broad pattern. So first of all, we're going to select everything that we can see on the screen here, which you can do by pressing the letter A for all, so that's select all. And then we're going to narrow the selection down to just the things that we want, which you can do by clicking on these various labels in the selection info window on the right. Each label has two parts that you can click on. The first part is the word in the middle of the label, and the second part is the little X on the end of the label. If you click the X, then everything matching that label is removed from the selection. So in this case, for example, we have 53 things selected here whose classification is connector, and those are all the small pieces of pipe or path that the model has introduced to join up buildings to the road network. So we could kick those out by clicking the X, and you can see on the map a bunch of them have disappeared. They've been deselected, and indeed the total number of things selected has gone down. And we could repeat this if we liked through all of the different classifications. I could say take away all the footways, that's got rid of a bunch more, and so on and so forth. Or more quickly, we could simply say up here on the type row, let's deselect all of the paths, and that's left us with a selection of only the buildings. There is another way that we could do this, which would be to select all and then just click where it says building to select just the buildings from that original selection. So this is a very common pattern in using the tool, is you select everything and then you narrow the selection down to what you actually wanted. So now that we've got our 60 buildings chosen, we can press the letter C, turns them all red. So they are now all compulsory, required, which you can see here in the constraint status section of the info window. And we're ready to run our problem. So let's give it a name. Let's call it training map 1 and press save. So we've saved our problem and now we're ready to run. So let's kick it off by clicking optimize up here. Now we'll have to wait for a little while as the problem is converted into another form and then solved. So after a brief wait, we can see the results. The color coding on the map is the first indication that something has changed. There are a few different colors here which mean a few different things. So first of all, let's talk about the colors that we're familiar with and what they mean in this new context where there's a solution. So you can see that there's a bunch of bits that are blue here. These are things which were optional and did get included into the resulting solution. So we allowed the model to use this piece of path for putting in a pipe, and in fact it chose to do so. Next, we have things that are yellow. So these are things where we did allow the model to consider them. So you can see here the constraint is still optional, but the model decided that it didn't need to use those things in the solution, or the solution wasn't improved by including those things. And so they have not actually been put into the answer. So you can see here there's a few little bits of paths that weren't necessary for building a network that spanned all of these buildings. And finally, there's one more new color visible on the map, which is these things that are a kind of magenta. Magenta elements are things which were not possible to connect to the network at all, so that there's no way in which they could have been connected. And this is usually because the topology of what we've drawn doesn't offer any route between the supply location and the building that we're talking about. So in the case of this building, you can see, if I zoom in on it a little, that there are no paths connecting it to the network. It's all on its own. And so even though we demanded that it be included in the solution, the model has recognized that that's essentially not possible, and so hasn't included it. You can see also a few small bits of path that are also colored magenta, and as you can see here, it says in solution impossible. So these are usually bits of path that don't go anywhere. So this little spur here off the end doesn't connect to any building, and so the model has omitted it from consideration. And finally, you can see that all of the remaining buildings are red, and that indicates essentially that they were connected up to a network by the solution, but they're red just to show that they were required, they're still required, and they were successfully connected. So this color coding tells us about what's gone into the network and is also reflected in rows in the selection info panel, which you can use to examine the things which did go into the network. So repeating what we were doing before, I've just pressed A to select all, and now I can scroll down in here to say, well, which things did we include? And you can see here this in solution row tells us about the three ways things could have gone. There's things which are in a network, things which couldn't go in, and things which weren't in a network. So we could focus just on the elements that did get used by clicking on network. And you can see this is the sort of the resulting network. If we wanted to select just the roads that were involved now, we could scroll up and select just path, and this is the pipe work that the model has decided to construct for us. So now that we have a solution, we can also view a certain amount of quantitative information about the results, so what THERMOS thinks about the network that we've built. A lot of this is visible on the map through the selection info window. So for example, if I click on this supply location, we can see a few additional rows have appeared down here. Coincidence, this tells us the coincidence factor that's being assumed for adding up the peaks of all of the buildings downstream from the supply. And we can see that the model has decided on that basis that it needs to purchase 1.589 megawatts of heat capacity at peak. And you can also see that the plant or selling heat from this location is bringing in a sorry, that's not correct. This is the revenue from the heat being purchased within this building. So yeah, there's a little bit of information about the supply there. These other facts are about the demand in this building, so it's a little bit confusing perhaps. Similarly, we can see some new information about individual bits of pipework that have been included in the system. So you can see here, this piece of pipework was sized assuming a coincidence factor of 75% for the demands downstream of it, which is a resulting pipe capacity of 238 odd kilowatts of heat. And to supply that heat would imply a pipe of around 48 millimeters in diameter at a cost of about 19,000 currency. And this section of pipe also has some associated heat losses, so 10 megawatt hours a year or 22 watts per meter. So you can see a few bits of kind of summary information about each building. You can see, this building's paying us £3,000 a year for its heat, or 3,000 revenue a year for its heat, that sort of thing. You can also see a summary page which will tell you about the economics of the solution as a whole by clicking up here on the THERMOS logo in the top left, which will bring up this menu which lets you see some other pages, and we'll go into the details of some of these other pages in a later video. But for now, let's go and look at the solution summary down here under solution, and that displays information about the overall solution in a nice set of tables. So you can see a cost summary which tells you what we spent, what the net present value of that was, how much heat we're buying, what the capital cost of the plant was, what the ongoing costs are. You can see how much revenue we're receiving from what we've connected up, and the italic rows are sort of sum totals for, in this case, the whole heat network. The model can also consider individual heating systems as a sort of counterfactual, but we haven't turned that on. We'll look at that later. And then you get, at the end, a final figure telling you about the NPV of the whole system, and on this row, the NPV of the network. So in this case, our network is slightly unprofitable. Reason for that being presumably that the heat price difference doesn't really cover the costs that we've set up. Scrolling down a bit, we can see a bit more information about some of the other, a bit more detail about some of what we've put in. So there's this card which tells us about the pipework that we've procured in the network, and how much that cost, what the losses were, how much heat capacity, how much length at different diameters, what type of surface we were digging up, that sort of thing. We can see information about all of the buildings that we've connected, how much money we're getting from them, how much peak demand they have associated with them, how much annual total demand they require. We can see the supply locations that we've built. Again, this is the same information we were looking at through the map. So 1.5 megawatts of supply, 63% coincidence factor. And finally, we can see a little information about how much carbon emissions or other emissions we're producing. There's a net row which is against a counterfactual, but we haven't set up any counterfactual in this case. So we're just saying 951 tons a year of CO2 as a result of supplying this heat. And finally, there's a little bit of summary information about the optimization, which is mostly of technical interest. So that's probably the size of it for this video. We've covered how to create a map, how to create a project, and then within a map, how to set up a network and ask the model to choose piping routes within that network and where to look at the costs. Next time, we'll talk a little bit about the optimization decisions, how you can control those optimization decisions, and the parameters that affect them. If you've enjoyed this video, why not try using some of what you've learned to answer some questions for a place that you're connected to? You could make a map for your area, and you could use that map to answer a few questions about the area. You could find out the total annual heat demand. You could find out the total peak heat demand. You could draw a network and evaluate it, or draw a few different networks and evaluate them and see how they compare. You could change the heat price to see how that affects the NPV of the solution that gets produced. You could look on the map at the coincidence factor for pipe work in the network and see how it changes according to how far up or down the network the pipe is. These are all ideas that we think might help you cement some of the lessons that we hope you've learned from watching this video. Please let us know if you have any questions or comments on what we've produced so far, the model, the application, and if you have any ideas about what you'd like us to talk about in the next training video. Thank you very much, and goodbye for now.